So the title of this symposium is Norms and Commitments in Human-Robot Cooperative Interactions. And in this introduction, I want to say just a few words about the rationale for this symposium. In recent years, there's been a fast expansion of the field of social robotics, with important efforts and abundant resources dedicated to the design and manufacture of robots for use in a number of social contexts, such as, for instance, companionship to the elderly, education, therapy, service, and so forth. To make further, I mean, actually, at present, the capacities of these robots remain pretty limited or context dependent. To make further progress, research in human-robot interaction, so HRI in the lingo, has explored various avenues. Sorry, I have to. Approaches toward making robots more capable of interacting meaningfully with humans. And in this effort, HRI research has taken inspiration from work in psychology, in philosophy of mind, and in neuroscience regarding human-human interactions. However, this enterprise confronts many challenges. The first range of challenges or series of challenges are motivational challenges. Humans are social animals. They exhibit a robust motivation to engage with others. This motivation has a number of sources, both endogenous, like the need to belong or a general pro-social tendency, or exogenous, like the existence of social pressure. And it plays a crucial role, this motivation, in explaining why people engage in joint action with human partners and why they remain engaged in a joint action even when more attractive options emerge. In contrast, humans appear much less motivated to engage in joint action with robots, exhibiting somewhat negative attitudes. So everyone knows about the uncanny valley effect, where the more robots looks like a human, the more creepy it feels and the more uncomfortable people are around the robot. But there are also other forms of distrust towards robots. So people tend to have at least implicit negative attitudes towards robots, even if they have positive attitude. Their levels of trust are usually lower than for human partners, and so on and so forth. A second type of challenges are what you might call predictive challenges. Successful cooperation is premised on the ability to predict what your partners will do. So agents need to coordinate their actions at various levels, and to do so, they need to make accurate predictions regarding their partner's actions and their consequences. And in human-human interactions, a variety of processes and devices that range from automatic processes of motor resonance all the way to explicit communications and commitments help us predict the actions of our partners. However, research on human-robot interactions suggests that prediction can be a serious challenge for human-robot interactions. Robots are often cognitively opaque to their human partners. For instance, findings in psychology and neuroscience suggest that humans interact differently and do not deploy the same range of predictive processes when their partner is a robot rather than a human. In addition, the gap that there often is between the expected and the actual capabilities of the robot may also impact the predictive capacities of humans. So in order to try and meet these challenges, there are currently two main broad approaches in social robotics. One approach uses behavioral strategy, and these strategies emphasize the need to build robots whose appearance and behavior appeal to human positive emotions and exploit human tendencies toward anthropomorphism. So you have cute robots like Pepper, for instance. Cognitive strategies, in contrast, attempt to identify and characterize the fundamental social capacities deployed in human-human interactions in order to design robots with similar capacities for understanding the behavior or the mental states of their human partners. And these cognitive strategies are exemplified by the work of a number of laboratories that attempt to design robots with social capacities such as joint attention, capacity to understand gestures and gaze directions, or a capacity for theory of mind. Now, there are a number of limitations with or concerns with this approach. First, with regard to what I termed behavioral strategies, one concern is that this approach is pretty shallow. Equipping a robot, say, with a capacity for bodily and facial expressions of emotions may appeal to humans and go some way towards alleviating the motivational challenge. But insofar as these emotional expressions do not reflect actual emotional understanding, this positive impression may be short-lived and predictive challenges made more acute. There are also ethical concerns with this approach. It can be argued that the way in which these robots engage with humans is unethical, as it exploits human emotional openness and vulnerability simply to improve the technical quality of interactions. And these may be thought to violate users' integrity, to create the risk that they become emotionally dependent on such robots, be hurt, suffer depression, and develop mental and physical illnesses. Cognitive strategies have also a number of drawbacks. On the one hand, there are important, there's the issue of computational costs. So far, attempts at endowing robots with social cognitive capacities have operated in piecemeal fashion. So this robot has some capacity for joint attention, that robot has some capacity for mind reading, that robot has some capacity for an interpretation of gestures. But they don't have all these capacities, and the computational costs involved in building all these capacities in a single robot would be extremely high, making the prospect quite possibly unrealistic. And second, assuming that this still could be achieved, there are ethical concerns. How should we treat these robots? Should they be treated as social agents worthy of moral consideration? So what we're trying to do in this symposium is to try and assess the merits of a third approach, an approach that emphasizes the importance of norms and commitments in cooperative interactions. So the question then is, to what extent can an appeal to norms and commitments in shaping human-robots cooperative interactions help mitigate the motivational and predictive challenges I outlined, and also possibly ethical and computational challenges? What could be the benefits or as well the drawbacks of such an approach compared to other strategies? So we'll have three speakers. We start with Raul Hakli, who will tell us about cooperative interactions with social robots and the sense in which robots can be said to be social. Then Ingar will tell us about the role of social norms in human-robot interaction, and John will present us some empirical work on the sense of commitment in human-robot interaction. So,
thank you, Elisabeth. I guess I can now again try to share my screen. And again, for some reason, I don't immediately see this in one of the options, my slides, but I will try again. And It's here, I think. Can you see it now?
Yeah.
Good. So, and how much time do I now have? 30?
About 20 minutes plus 5 minutes discussion, and then we'll have a general discussion at the end.
20 plus 5. So my topic today is cooperative interactions with social robots, and this presentation draws from some joint publications with Pekka Mäkelä and a forthcoming publication with Orly Klodik and Victor Fernandez Castro. So the problem is that the cooperative interaction, the idea of cooperative interaction between humans and robots presents several challenges, as Elisabeth told. There is the motivational challenge. Why engage in social interaction with robots? We are social animals, but somehow we appear much less prone to engage in interactions with robots. So maybe there's something missing from proper social interaction. The other is a predictive challenge. How to engage in social interactions with robots, how to predict their actions, how to coordinate with them. And I will try to address these practical challenges in my talk, but I'll do it indirectly. So I'm considering a theoretical challenge first. So how to even describe interaction between humans and robots? Is it social interaction in the first place? And this, I think that might help alleviating these problems, because some of the difficulties in these practical challenges may in fact stem from this difficulty to even understand the nature of these interactions. If it is social interaction, then how come it doesn't really satisfy my need for social interaction in the same way that relationship between human beings do? And also, if it is social interaction, how come my usual social practices and ways of behaving don't always apply, but they break down? So that's the question. And if it isn't social interaction in the first place, then why should I engage in it? Because it doesn't address my need for social interaction. So these are the questions. And also, if it isn't, then how do I engage with them? How do I predict their actions if I can't use my usual methods of social interaction? So the question is, what is sociality, and can robots be social? And if you look at the definitions of sociality, in sociology and philosophically, sociality is typically considered to be a property or relation of human beings, between human beings or persons. In biological sciences, sociality is thought to be a relation between organisms of the same species. And that neither of these really work well for human-robot interaction. Then there are some accounts that allow for pretty much anything to count as social, insofar as it somehow has some causal effect in relations between agents. For instance, Latour's ant theory. So none of these seem to be really helpful in understanding the type of interaction that we're talking about here between different types of agents with asymmetric capabilities, humans and robots. So, but in order to make some progress, let's now start from some of these accounts. And I guess we should start with these accounts that talk about human social interaction, because humans are at least one party in this human-robot interaction. And then try to see whether we can understand human-robot interaction in the light of them. But we very soon realize that there are two problems. One is that these require intentionality, and the other one is that they require properties beyond intentionality, like personhood or normative properties. So as to the first problem, there are some standard approaches, even though we can say that in some real or strong sense of intentionality, robots might not apply for intentional agents. For instance, Searle's famous Chinese room thought experiment is one argument for this, and it's a pretty strong argument. But there are some approaches that allow ascribing intentional attitudes to robots, for instance, functionalism or Dennettian interpretationism. And I will now adopt this Dennett's idea of an intentional stance. And you all know the story. I mean, we encounter different kinds of objects and we try to understand how they behave. We try to explain their behavior and predict how they will behave in the future. And with natural objects like sticks and stones, we can just explain and predict their behavior based on their material properties. And this is the physical stance. But sometimes this is not enough. When we encounter some complicated artifacts, like going to a building and there's a lift there, we don't really need it, we don't really know enough of its material properties so that we could understand its functioning and predict how it will work. But we know that it's there for a certain purpose, there is a function, and the function is to take people from one story to another, and understanding these functions may help us to understand how it's going to work if I press certain buttons and so on. But then there are even more complicated objects that we try to understand, animals and human beings, and they can't really be approached from mere physical stance or design stance, but we have to attribute goals and beliefs and so on, and some sort of rational capacities to understand how they will behave. And I'm here taking this to be an instrumentalistic, I mean, I'm taking this instrumentalistically, so I'm not saying, like Dennett sometimes say, that this is all that there is to intentionality, but I think that at least we can say that this is a useful way of dealing and interacting with intentional agents, without saying that we could still maintain that, okay, in strict sense, robots are not really intentional agents and they don't have really beliefs and desires. Okay, but even if we deal with intentionality in this way, there are problems, because these theories of sociality demand much more, typically personhood. So consider, for instance, this is just one example. There are many examples to be found in the literature, but this is Margaret Gilbert. She gives a broad characterization of sociality, saying that a phenomenon is a social phenomenon if and only if it involves one person's being connected either mentally or in some causal way with another person or persons. So she's immediately restricting these social relationships to persons and personal relationships between persons. But there are further conditions. So moreover, Gilbert notes that such very broad notions of sociality that don't really characterize what kinds of connections there have to be are relatively uninteresting, and more demanding notions are required to understand the importance and nature of the notion of sociality. And she then defines sociality proper. What would sociality proper be? Well, Gilbert considers certain kinds of phenomena that might be marks of sociality, but argues for one phenomenon that, according to her, characterizes social life, and that's the plural subject. And we are, of course, familiar with this concept in this conference. But anyway, plural subject concepts involve multiple agents jointly committing themselves to actions or attitudes, seeing themselves as a we, and joint commitments are stronger than individual commitments and can only be rescinded by all the members together. Well, importantly, joint commitments entail obligations. And this is quite typical if you try to look at theories that try to specify what is really needed for sociality and social agency and social life. Very soon, strong normative notions and normative relationships between these agents come into play. So there are at least, or typically there are some features like this. They employ the concept of a person, they entail interpersonal normative relations like obligations, and they require high cognitive capacities. So how to deal with these hurdles for applying these accounts of sociality to other kinds of agents from human beings? Well, for one thing, I think that we can bracket the term person and instead focus on the actual capacities required above mere agency. So I think that this is justified because I would suspect that the term person is not really supposed to do much theoretical work, but it's rather just that these theorists take the human social relationships as a paradigm example, that they are interested in it, and they just use this person merely as a natural selection of words. So I think that we can we can relax that condition and just talk about agents, and then study what above mere agency is needed. Then interpersonal normative relations, we could try to adopt some approach that does not require them. For instance, Bratman has an account of sociality that doesn't use strong normative notions. Well, that's one approach, but I think, and this is in line of this workshop, I think that these normative notions are all over the place in human social relationships and human social life. So to get rid of them would really make the accounts too poor. And I would like to hold on to that, to these normative notions. We could also try to use the current popular strategy of minimalizing to strip down conditions that seem too demanding for children, animals, or possibly robots. I mean, this is also this getting rid of normative notions would be an attempt in this direction, but most often these approaches are used in terms of getting rid of these cognitive conditions that seem too demanding for children and animals. This doesn't really now concern us very much because the cognitive capacities are not really the problem for robots that can actually do pretty nice inferences very easily. So, but in any case, I'm not going to this this direction. I don't now try to want to loosen the conditions of sociality, but rather I will maintain that, okay, in strict sense, this is what sociality proper is. It is something strong. It involves some kind of normative relations and probably quite sophisticated cognitive conditions as well. Okay, but then how to account for sociality for robots? I mean, because arguably they fall short of personhood and are incapable of entering into normative interpersonal relationships. And why is that? Well, here is an argument that I have presented with Pekka Mäkelä to the effect that robots are not really autonomous agents. And I will go through this very briefly because this is not my main topic in this talk, but the idea is that we are employing Al Mealy's history-sensitive externalism here. And according to that, whether agents are autonomous, it depends on their causal histories, how they came to possess the attitudes, values, and capacities that they currently have. These have to be authentic. And what authenticity means in Mealy's terminology, it is, he doesn't give a positive characterization, but he rules out some cases. And for instance, manipulation of an agent's capacities or values undermines their authenticity and hence the agent's autonomy. This is the second premise. Okay, and then we have argued that, well, robots cannot really achieve their capacities or values without programming and engineering. This is, well, we take it to be almost a conceptual truth that robots are engineered artifacts. So, and fourth premise is that programming and engineering count as manipulation. It is, Mealy doesn't talk about programming because he doesn't consider robots, but he considers cases like hypnotizing someone to do something or brainwashing and things like that. These are manipulation, but we think that also programming and engineering should be understood as manipulation in this sense. And hence, even if we could implement robots that have all the capacities that are standardly required for autonomy, there are now many accounts, of course, but for instance, choosing their goals, acting for reasons, and things like that, these capacities and values on which they are based would not be authentic. And hence, robots cannot really be autonomous in the sense relevant for personhood and moral responsibility and these philosophically loaded concepts. They can only be autonomous in this engineering sense that requires that they can act without continuous control. Well, if this is correct, it affects the moral or normative status of robots, and they cannot bear moral responsibility. They are not persons or moral agents with rights and obligations. arguably then they are also not proper subjects of social commitments, because social commitments involve obligations, obligations to others. Also, arguably, they are not proper objects of trust. I'm not going to go through this in detail, but there's a nice paper by Catherine Hawley who argues that trustworthiness and hence being a proper object of trust requires commitments or obligations. Robots are not properly subject to norms, again, arguably. Robots cannot be proper participants in joint actions, at least under the Gilbertian views. And hence it seems that the robots lack several important capacities that are required in proper social interaction. And hence it seems that they are not proper social agents. However, they can still do many things, as we know. So on a behavioral level, robots may be able to do many things that we can. So they can behave in ways that seems committed, and we can even experience a sense of commitment towards them. Also, I think that we can have trust feelings towards them, even though they aren't really proper objects of trust. They can recognize social norms, they can act in accordance with them, they can make predictions about others' behavior based on norms and practices, and so on. They can also be programmed to coordinate their actions with others, behave in ways that joint action participants in human joint actions do. And this is something that I have also engaged in and tried to suggest ways of cooperative planning and team reasoning with robots. So all this leads to an idea that these sophisticated behavioral capacities suggest that we might have this, what I'm calling social stance towards robots. So just like Dennett had the idea of treating someone as intentional agent if their behavior requires postulation of certain kinds of intentional states and certain rational capacities, we can apply the same approach to sociality. So certain kinds of behavior are best explained and predicted by attributing to the objects that we are observing certain social features and capacities. So for instance, if we observe someone hurrying to another place, so we have taken an intentional stance, we have postulated some beliefs and desires to this agent, but then the behavior, expected behavior deviates from what we expected. So for some reason, even though she seems to be in a hurry, she constantly stops in crossings where there's a red light in front of them. And it's very difficult to explain from the mere intentional stance. I mean, do they have really such a strong desire to always watch red lights if possible? And it doesn't seem to be the case with other red lights, because for instance, if the red light is facing to another direction, they don't go there and look at that. But no, they just continue on the way. So just ordinary instrumental beliefs and desires don't really very easily seem to explain their behavior. But it becomes very easy to explain their behavior if we attribute to them a recognition of a social norm that you should stop whenever there is a red light on your way. So what I'm saying now is that this is a case of taking a social stance towards the agent. Certain kind of behavior demands an explanation, and if the explanation refers to the existence of social norms, then we are warranted to take a social stance and postulate that this agent has certain kinds of social capacities. Another example involving a robot, we may see a robot in a museum or a hospital or somewhere going through different rooms from one room to another, and then we see that all of a sudden the robot deviates from the shortest route to the next point in order to avoid going in between two people who are discussing, even though there would be room to go there, but for some reason it goes further in order not to. Well, what is the reason? Probably we have to explain it via some acknowledgement of a social norm that you shouldn't bother people who are engaged in a conversation or something like this. So we can take an agent to be a social agent, in this stance sense whenever its behavior is best explained and predicted by postulating to it sensitivity and responsiveness to other agents and some understanding of social norms and conventions. This is the idea. What kinds of behaviors then suggest taking a social stance? Well, one thing is the sensitivity to agency. We can distinguish between agents and non-agents, adjust behavior based on others' responses. I mean, now I'm talking about the object that we are observing. For instance, a robot. If we see that it behaves differently towards agents from non-agents, then this is a suggestion that there might be some social capabilities. Tendency for interaction, seeking contact to other agents, perhaps attempt to communicate own intentions, perhaps even engagement in joint activities. These would be very strong indicators of some social capabilities. Sensitivity to conventions, social norms, and roles. Those behaviors suggest taking a social stance, which then leads to postulating some basic capacities for social cognition, like action coordination, mind reading, higher order intentionality, some social motivations, which may be various kinds, basic normative understanding, recognition of norms and conventions, expectations of others' norm compliance, and their expectation of own norm compliance. And more about this in the Robot Philosophy Conference that is going to be held online next month. So, what are the benefits of this idea of taking a social stance? Well, this gives some justification for talking about social robots in the first place. So this is the sense in which robots, I think, can be legitimately called social. We can talk about social robots, but we can still think that, okay, it's not really the same thing as human sociality. They're not persons, they are not social in the same sense as we are. But we can also see that this is not just a psychological tendency to anthropomorphize, like say. I mean, I think that anthropomorphization is precisely this, taking a social stance towards someone. But this is not just a random psychological tendency, but actually, just like intentional stance, it has a rationale. We can adopt this stance to explain and predict an agent's behavior. So, for instance, a robot. And we can use our standard social skills and practices, but we can also understand its limitations. So, this idea allows roboticists to design features that employ our social skills, and because it provides a category between mere agency and then full personhood, also perhaps helps them to avoid creating functionalities and features that create too high expectations. That would lead arguably to the predictive challenge and the motivational challenge. So a more general lesson is here. So in order to tackle the motivational and predictive challenges, it's important to understand this as a general human tendency, that we take different stances in order to explain and predict different kinds of behavior. So observing certain type of behavior creates a need for explanation. Certain kind of an explanation postulates certain kinds of capacities. And then once we have postulated these capacities, we of course make predictions of future behavior that these capacities allow. And if it happens that our expectations turn out to be false, then we encounter problems in coordination, which leads to the predictive challenge, which in turn may lead to frustration and lower motivation to engage in interaction. This is the motivational challenge. So for instance, if we see a robot that displays a nice smile and
sorry, Raul, it's time to stop.
Yes, okay. Anyway, this is something that we should avoid. So we should avoid creating an emotional stance in order not to create false expectations that will be disappointed. So it's hardly news for roboticists, but it shows the generalizability of the Dennettian approach. So I will go through these. And the conclusion is that this social stance allows people to cooperatively interact and coordinate their actions using standard social cognition capacities. For roboticists to employ social vocabulary and understanding of social cognition, but also avoid going too far, and theories to maintain that still, strictly speaking, robots do not count as proper social agents or persons accountable for their actions. Thank you. Here are some references.
Oh, thanks a lot, Raul. So now we have 5 minutes for questions, and then we'll have a general discussion at the end. So you can also ask questions at that time. So we can clap virtually. Thank you. Thank
you.
If you have questions now, I can see all of you, so you can raise your hand or use a hand to indicate that you want to ask a question. So Michael Wilby.
Hello, thanks for the talk, Raul. I think I was wondering about your use of Dennett and the way in which you, rather than taking what I take Dennett's approach to be, to say that intentionality is nothing more than what you get from the intentional stance, you seem to want to separate off it as an instrumental thing and then say, well, there are these real intentional states, but maybe you should take the intentional stance for your purposes as just being this instrumental thing. And I wonder whether that just ended up back being in a position of anthropomorphizing the robots, partially because I think stances can be kind of overgeneralized quite a lot, or at least that seems to be a problem which happens with stances for Dennett. So he has that problem of kind of, what do you say about a lectern in the middle of the room? Well, you can take the intentional stance and say that it kind of wants to be in the middle of the room and this is the best place it can be. So whether you end up with that kind of problem, because you can, you know, so if you project the intentional stance onto the robots or the social stance onto the robots, then you will just see them as being acting for social reasons. I'm trying to work out exactly.
Yeah. Yes, I mean, this may be true. I mean, I want to be non-committal. I mean, in the sense that I prefer the instrumental understanding of this stance, even though Dennett himself may say that this is all that there is into intentionality, but I really don't understand that because it seems that this interpreting someone's action is already an intentional. It's already intentional, so I can't really understand how it could be more than something instrumental. Whether they overgeneralize, I think that is a problem, and maybe a problem, and that's why I said that first of all, I think that there is this middle category, something more than mere agency, but not quite personhood, and it would be nice to specify what exactly are these conditions for social agency, precisely so that we don't overgeneralize and infer or postulate too strong capacities to these social agents in this sense. And also I think that it could be refined still further. I mean, because there are many kinds of types of, the anthropomorphization involves not just these social features that I was talking about, but precisely there might be an emotional stance. There might be a linguistic stance. If a robot greets us or asks us a question, we invoke a linguistic stance and postulate that, okay, this robot can enter into dialogues, maybe has semantic understanding and so on. If it displays a happy face or sad face or something like that, we have an emotional stance and postulate capacity to have emotions, recognize emotions, and engage emotionally. And that's precisely what I would like to pay attention to, that there are these different kinds of stances involved, and we should pay attention to them.
So we have time for one more question before. So John?
Yeah, Raul, thanks for the great talk.
Oh.
Wondering what you think about an objection that people sometimes made to Dennett, that if you take the intentional stance and it works well as a generates accurate predictions, then doesn't that give us a reason to think that those descriptions are true? So I think Fodor called this the, if it isn't true, why does it work objection? So so if we take that line of thought, doesn't taking the social stance towards robots give it, if it's useful and effective, give us reason to think that it's actually not just just a mere instrumental stance, but actually true?
Sure, it might give some reason to think so. I just don't think that it's sufficient reason to think so. So I would still prefer to remain non-committal in this. I think that there is something more involved in our human social relationships than this stance approach.
Okay, so a final one, Anna.
So I really enjoyed the topic. That's the thing I'm thinking about all summer. But I have a question. If you take the stance that you say it's not really social, we just do the as if game or pretend, aren't you forced to say that if my daughter is playing with her puppet or with a car, that this, and she is treating her puppet as if, that this is a social interaction as well?
But the puppet is not behaving in any social way.
Yeah, but humans are able to do everything what you describe, what we do in front of robots.
Yes, but we can explain the puppet's behavior totally without any reference to anything social, like responsiveness to other agents or understanding of social norms. I mean, the puppet doesn't do anything. It's just pure fiction. We're it's just a pretend play. But now I'm talking about this stance that is required to explain the behavior of the object that we are observing. If in order to understand and predict the behavior requires postulating certain capacities for social interaction, then the social stance is warranted.
Okay, I'm not yet convinced, but maybe we talk later.
Yes, definitely we will. Looking forward.
Yeah, thanks.
Thanks a lot, Raul. Okay, remember we have a general discussion, so if you have questions for Raul or at the end for all of us, we still have time. So Ingar, are you ready, or do you want John to speak second? Ingar.
Yes, do you hear me? Can you hear me? Yes.
Okay.
Well, maybe if he can do it, it would be better, because then I'm finished, but then I can calm down. Okay,
right.
and listen.
Okay, so
yeah.
relax.
Is it all right? Yes.
That's fine with John.
Thanks.
So we'll have John now, and John will talk to us about the sense of commitment in human-robot interactions.
Okay, are you seeing my slide here?
Yeah.
Great. Okay, so
perhaps
yes.
you can use the presenter mode this way.
Oh yeah. Is that better?
Oh. Well, that's fine. Okay, let's do it.
What are you seeing?
No, because I see what you see when you're presenting. So not just this one slide, but
it's a bit much. Yeah.
Here we see your notes and the next slide.
Maybe this is easier. Is this? What do you see now?
That should be play from start, I guess.
Aha! How about this?
Right.
That's good. Okay. Thanks. Yeah. Okay. Right. So as Elisabeth was saying at the beginning, as robots are becoming increasingly prevalent in many domains of everyday life, we can expect more and more research to be devoted to the optimization of human-robot interaction. And in this regard, it'll be important not only to continuously improve safety and efficiency, but also to develop ways of making people feel comfortable and motivated to interact with robots. And I'll be presenting some recent theoretical and empirical research bearing on this set of issues, and in particular on the second challenge that Elisabeth identified, namely how to maintain people's motivation to interact with robots. And I think that commitment is an important tool in meeting this challenge, because commitments stabilize agents' motivation to contribute to joint actions, for example. And in so doing, they support planning and coordination of large-scale activities involving multiple agents that unfold over different timescales. And they also support cooperation, making people willing to do things they wouldn't otherwise be willing to do. A construction worker, for example, is going to be much more motivated to show up every day on the job and do her job if somebody has made a credible commitment to pay her for it at the end of the month. So I'm going to start out by telling you a little bit about the theoretical framework that we've been working with, and then I'll present a few studies that we've done, and I'll close with some implications for collective intentionality debates. So first of all, what I do not mean in talking about commitment in the context of this talk is what we might call commitment in the strict sense, as philosophers in the collective intentionality debate have typically understood it, namely as a relation among two agents and an action X, such that B, the second agent, has an obligation to the first agent, A, to do X because B has intentionally expressed her willingness to do X under conditions of common knowledge, and this has been acknowledged. So yeah, now when these conditions are met, A is now entitled to expect B to do X and can rely on that. She's entitled to rely on that expectation, and B has an obligation to A to do X. So this is a perfectly good characterization of many instances of commitment, in particular those arising through promises or other forms of verbal assurance. But I'm going to suggest that it's not a, well, it has certain limitations. One, it's a binary notion, so either these conditions are met or they aren't. So it doesn't enable us to think of degrees of commitment. Secondly, it's not well suited to helping us to identify when implicit commitments would arise, or more generally, when commitments would arise in the absence of promises or explicit verbal assurances. And most importantly, this obviously is a normative notion. So what I'm going to be doing is starting out with a psychological notion rather than a normative notion. And the psychological notion, as we'll see, enables us to see commitment as a psychological state that admits of degrees. So to illustrate some of the kinds of everyday cases of commitments in the absence, or psychological commitment in the absence of promises or explicit verbal assurances, an example from Margaret Gilbert. She asked us to consider these two people, Polly and Pam, who are in the habit of getting together and smoking a cigarette and chatting every day on their balcony at the same time every day. And they've never agreed to do this. They've never discussed it. They just are in the habit of doing it. And if one of them just doesn't show up one day, question is, has she violated a commitment? And so I think it's intuitive that it'll depend on various features of the context. So if they've done this every day for the past 5 years, it's going to seem much more like a commitment violation than if they've only done it for a week or two. Also, if the one who does show up has to walk up 5 flights of stairs to get to the balcony, and the other one knows this, then it's a lot more like a violation of a commitment if she hasn't done anything to try to warn her friend to let her know that she's not going to make it. So it seems factors like history of repetition and the investment of effort and potentially other costs are factors that can give rise to or enhance at least a sense of commitment, the psychological state. So to try to capture this psychological state and to develop a systematic approach to identifying factors that would modulate it, we have, in my group, we've been working with from a different starting point, rather than from starting out from this rich notion of commitment in the strict sense. We've started out from a very minimal analysis of the kinds of situation, the structure of situations in which the psychological sense of commitment might arise. So we've got an outcome, minimally, that is either desired by the first agent or is a goal toward which that first agent is acting. And in order for that outcome to be achieved, there's a crucial external contribution, this X, which needs to be made by the second agent, B. So in situations with this structure, we can say that B, the second agent, has a sense of being committed to performing X to the extent that B is motivated by her belief that A expects her to contribute X and may be relying on that expectation. So clearly this, in speaking of motivation, which we often operationalize, as I'll explain in a moment, in terms of persistence, we have a graded notion. And anything that modulates motivation or the willingness to persist will be a factor modulating the sense of commitment. So things like repetition that I identified earlier, costs, I'll say a bit more about coordination in a little while. Any factor that modulates motivation in situations with that structure will modulate the sense of commitment. So I think that this construct is useful for HRI because the sense of commitment can be important in sustaining motivation in the face of kinds of situations that roboticists are worried about. So underperformance, robots having to adjust to new situations, unpredictable situations, making errors, breaking down, having to recalibrate occasionally, and which is just boring and annoying. And there's the concern that people will lose patience interacting with robots. So things that can, or factors like a sense of commitment that might stabilize, help them to sustain motivation would be quite useful. Also overperformance, it's maybe a bit counterintuitive, but there's also research suggesting that if people are working with automated systems that are too efficient, too effective, like an autopilot that does too good a job, that people zone out and they don't then do their part at all, which could be a very important kind of monitoring role, for example. And also just more generally boosting humans' motivation to engage in beneficial but potentially boring or effortful activities like physical therapy, skills training, where just like in the other context where doing something together with a human who's investing effort, for example, might make you feel motivated and committed to do your part as well. That may also work in contexts where the agent that you're interacting with is a robot. Okay, so now some empirical research. First, looking at one of these factors that I identified, namely costs. And what we've done, just as a side note, in each of these instances, is we've started out from a kind of experimental setup that worked first with human-human interaction and then adapted it to human-robot interaction. So I'll first briefly explain the human-human experiment. So this was based on, oh, it says can't play the video. That's all right. So it's based on the old mobile phone game, The Snake, which you might remember. This little apple here, I don't know if you can see my cursor. Can you see my cursor? Oh, that's good. So these little apples appear on the screen, and you navigate a snake up and down to try to track down these apples. And in the standard version of the game, it gets increasingly exciting because the apples appear, or the snake moves ever more quickly, and the snake, you're not allowed to let it go off the screen or it'll die. So, and it gets longer and longer. But we devised a version of this that gets increasingly boring because the snake doesn't start going more and more quickly, but instead the apples appear at an ever slowing rate, so it just becomes tedious. We've also done versions of it where you have to hit the space bar over and over again, so it's not just boring, but really unpleasant to keep going. And we measure people's commitment in terms of how long they keep going. And crucially, we told people that they're playing the game together with a partner. So the partner, we tell them, it's actually an algorithm, but we tell them that the partner is operating the y-axis with the up and down arrows, and they're operating the x-axis. So they're jointly controlling the snake. And for each round of the snake game, they're told that their partner has to do a cognitive task to unlock the next round, which could be, for example, to solve a CAPTCHA. And a CAPTCHA can be either relatively short and easy, like this one on the left, or relatively long and blurry, so that it requires more cognitive effort to unlock the next round of the game. And so yeah, they see little stars appearing on the screen, like you'll see here in a second, that indicates that their partner is entering the characters of the CAPTCHA. And you can see it looks kind of effortful as these stars appear. And then they play around the snake game, and we measure how long they keep going. And lo and behold, what we see is in the high effort condition, the longer CAPTCHAs, they persist longer than in the low effort condition. In a second experiment, we told them that the partner was just an algorithm, and then we see no difference. Okay, but then now in a third experiment, we told them that their partner is this humanoid robot, the iCub. And we showed them videos of their partner, the iCub, practicing CAPTCHAs and practicing the snake game. And then they do the very same experiment, and they're told that their partner that they're connected with through the internet is the iCub, and we see the same pattern as with human partners. So that's published in this paper here that came out last year. So it seems that we have here at least some evidence that the perception that your partner, even if it's a robot partner, investing cognitive effort into a joint action lead you to at least act as though you feel committed to putting in a bit more effort yourself. What about other kinds of effort? So that was cognitive effort. We were also interested in looking at physical effort. And one kind of physical effort that we thought might be particularly relevant and interesting would be adapting your action kinematics, adapting your movements to make your movements more predictable or intelligible to somebody that you're interacting with. So this is inspired by research on motionese in developmental psychology. So motionese is a term that developmental psychologists use to refer to this kind of way of moving that people intuitively adapt when interacting with children. So making bigger movements more slowly, longer pauses between movements, which I think there's some evidence also that we do that also with adults when we're teaching them something. But it was first used in the context of developmental psychology. So we devised a task where the robot teaches the human participant a sequence of movements. You can see here on the right a typical sequence of movements. And then the human is supposed to repeat the movements. And then the robot repeats the demonstration a second time. And yeah, I think I'm not going to wait for this video to go all the way to the end, but you can see that you should be able to see on the left, it's a bit more slow. And he has longer pauses in between the movements. So, okay, so what happens is basically the robot shows the participant first a sequence of movements at an intermediate speed and with intermediate pause durations. So that's the medium effort condition. And then in one condition from there, the robot slows down, that's the high effort condition, and introduces longer pauses between movements when repeating it. And in the other condition, he speeds up and has shorter pauses, like he's getting impatient with the stupid human participant. And yeah, so one group had first the high effort condition and then the low, and another group of participants had the other way around. So we measured learning performance, how well the people learn from these distinct demonstrations, and also their own willingness to reciprocally adapt their kinematic effort in teaching the robot a skill. So they, after each block of demonstrations of that sequence of movements, the participants then have a task of teaching the robot to read letters that are written with one's finger, like this, in the air in front of the robot. And so again, as in the task where the robot is teaching the participant, here the participant spells out a word and then the robot doesn't explicitly guess what it is because we don't want them to actually get feedback. The robot just says vague things like, oh, that was a pretty good demonstration. Can I see it one more time? And then we see what they do the second time. So what we see with the performance data is, here you can see we've separated it out because there were substantial order effects. We've separated out the two groups. So in the blue, you see the group that first had the low effort block and then the high effort block. And you see their performance increased. But basically, we have a main effect of the effort manipulation on people's performance. And in particular, that's because the group that starts out with the low effort and then moves to the high effort, their performance improves. So it seems to help performance to some extent. With respect to the kinematic data, so do people reciprocally adapt their kinematics? It's not super clear. What we do see is, so here these, on the y-axis on the left, you see the participant's velocity, and this is the difference in velocity between the first time the participant spells out the word and the second time. So it's how much they slow down. And negative numbers mean more slowing down. So basically in the first block, both groups just always slow down. In the second block, the group that first had the low and now has the high effort robot, they keep slowing down. But the group of participants that first had the high effort robot that was slowing down for them and so forth, they seem to sort of lose patience and they don't slow down for the robot anymore. And we see the same pattern for pause times. So it looks like if the robot is not going to continue being cooperative and slowing down and adapting its movements for them, they seem to get frustrated and do the same thing. And questionnaire data support that, which I'm just skipping over for the sake of time. How many minutes do I have left, just so I can calibrate?
I'm afraid I didn't check my watch when you started, but about 5 minutes, I would say.
Okay, that's fine. So maybe just, yeah, actually, I want to have plenty of time for discussion. I think there's another study that we did showing something similar. I'll just mention the hypothesis briefly. I'll just go through it a bit quickly. We have some evidence that where there's a high degree of coordination, people feel more committed to their interaction partners. And that the hypothesis is that where there's a high degree of coordination, then just by coordinating with you, your partner is clearly relying on expectations that they have about you, and they're making salient what they expect you to do. And so you feel pressure to conform to that expectation and avoid wasting their efforts in forming expectations and relying on you. And so we showed people videos, 2 versions of this task. In one, they're highly coordinated. In the other, they're not highly coordinated. And we asked people questions like, how long do you think the guy is going to persist? And, oh yeah, patience. So if the robot has to stop and recalibrate, and just how long would the human be willing to wait? And so what we see here is our manipulation didn't really work. I think it was too, yeah, it didn't. You can see in blue the high coordination condition, and in red the low coordination condition. And on the y-axis, their commitment score, so how persistent they thought the guy would be, and how patient they thought he would be. And you see there's no difference there. But what you also see is, we also asked them how coordinated they thought the interaction was. And we had a significant correlation. So the more coordinated they thought the interaction was, the more persistent and patient they thought the person would be. So that's consistent with the hypothesis. It's just that our manipulation seems not to have worked. Okay, so I'll just finish with a few points of identifying some possible implications. So one is, we seem to have some preliminary evidence, proof of concept, that a sense of commitment is possible in HRI. But what about commitment in the strict sense and other normative constructs? Well, actually, I might come back to that, but this is the more important point. So in thinking about norms, it's useful to look at what Christina Pacherie has to say about norms. So she defines social norms as informal rules that govern behavior in groups and societies. And she says a set of social norms specifies what is acceptable and what is not in a society or group. And she has listed these sufficient conditions for social norms. So we have to have empirical expectations. So individuals believe that a sufficiently large subset of the relevant group population conforms to the norm in situations of type S, and either of these other conditions has to be fulfilled. Normative expectations. So individuals believe that a sufficiently large subset of the relevant group population expects them to conform to the norm in the situation. Okay, so the main point there is that it's important for social norms what people think social norms are, what people expect, how they expect you to behave, and how they, what they would be willing to sanction you for. So even if you don't believe that you really have obligations to a robot, you don't really believe that there are commitments, and don't believe that social norms are applicable in HRI, other people may think otherwise. And our results seem to suggest that, well, that might be the case. And if that's the case, then that gives you a reason to act as though you believe social norms were applicable in HRI, because if you don't, people might sanction you for it. Okay, so that's just a sort of point of discussion to end on. Thanks.
Thanks a lot, John. Once again, we have time for 2 or 3 questions before we move on to our final speaker. So Anna Molchanova, sorry. Anna?
Actually, I didn't have a question, I just clapped.
Oh, sorry. Michael.
Oh, thank you. That was really interesting. I think it's actually something to do with your final point, which I kind of was thinking about, really, because I was thinking, because you separate off normative commitment and psychological commitment quite sharply, it seemed to me, early on. And when I think about commitment in myself, I often think of it as a normative thing. So I kind of think, well, you know, if I'm committed, then I really should be doing this action, or I should be behaving in this particular way. And when it came to the robot experiments which you had, I wondered whether at least part of the aspect of commitment might be, which the people who are involved are feeling, might not actually be towards the robots, but towards the circumstances they're in, including the experimenter, which kind of linked up a little bit with what you were saying at the end. Even if you don't actually feel that these things, you know, that you should actually behave in a certain way towards a robot, it might be that you feel that other people think you should. And so I was wondering how much you felt that might have gone into that kind of commitment which they had in those circumstances.
Yeah, thanks. Those are a couple of good points. So first, the commitment to the experimenter, I definitely think that that plays a role. So you might have noticed when I was presenting the results from the snake experiments that actually in the experiment where they are correctly told that they're just playing with an algorithm, they actually persist longer. And I speculate that that's because it's a boring task, and so there are countervailing social motivations. When they're playing with another person, they on the one hand think he's going to find this boring also, so I'm not going to do this for too long. But in the condition where the guy has put in, they think the person has put in more effort, then they persist a bit longer. So you've got these countervailing motivations, whereas in the experiment where they're told that it's just an algorithm, there's only the commitment to the experimenter, and there's no reason to sort of, in the interest of that other person, to hurry up. So that's why they persist longer. That's a speculation. But yeah, I think that's playing a role. But I think in the experiments where, with the humanoid robot, for example, I don't think that could explain the difference between conditions that we see. So why would they persist longer in a high effort than a low effort condition? But to what you also said about, maybe I made this distinction a bit strong between normative and non-normative. I also think that the relationship is more complicated and nuanced, and would be a good topic of discussion that I won't spend too much time on now. But yeah, I think you're right about that.
Other questions? Alessandro?
Thanks, John. This was very interesting. So I mean, this relates to some of the discussion that we had in the past. I was wondering, so whether you could tell us something more about what you think the sense of commitment is. I mean, it seems to me that it isn't simply the belief that I have a commitment, because that belief must be linked to some volitional states in order to motivate me to act. So what exactly, I mean, and also, you know, the term sense of is used in many different contexts and has many different meanings. So I was wondering if you could elaborate a little bit on, you know, what sort of state is the sense of commitment?
Yeah, thanks. Yeah, we have spoken a bit about this. So I think that we started out by defining it in functional terms. So that's compatible with different explanations of what it actually is in terms of psychological mechanisms. And I think that it's likely that there are multiple psychological mechanisms that play this functional role. So one is a kind of metacognitive state that regulates motivation because of beliefs or beliefs, right? So I mean, I don't have to believe that I'm committed to the robot. I might just kind of, I might think that maybe this is the case, and that's sufficient to trigger a regulative mechanism to maintain my motivation. So that would be a kind of a component of the executive function. But it could also be more a reward processing mechanism. So because somebody has invested effort in something, it just seems more rewarding intrinsically, so then I don't need top-down motivation. So that would be a different mechanism. And I think getting a better handle on what other mechanisms there might be and which of them are at play is a challenge for the next years.
All right, final questions before we move on to the next speaker. So Anna Molchanova, this time you really wanted to ask a question?
Yes. So I would like to ask, so if you could clarify what commitment is. So is it commitment to the task? Is it commitment to the other person or entity, or both? Because suppose you're doing something with another person and you really don't care for what you're doing, you just care for that person, right? And you at some point may even stop doing what you're doing and just kind of like keep talking to them or something like that, because you just want to show this. So it's kind of commitment to membership of some sort, right? Or like some people think that pets or animals in general are moral patients, so we kind of treat them well because we are committed to other members of human community, and we don't, you know, torture small animals for fun, right? So it's like, it's more like of a commitment to membership rather than to the project. Somebody may think that torturing small animals for fun is great, but they won't do it because humans don't do it, generally speaking. So like, if you could clarify what commitment means in your research here.
Yeah, so we've started out, for simplicity's sake, thinking of commitment to do a particular task with a particular other agent. And so we would have to, I mean, I think clearly you're right that sometimes, because I'm committed to a person, the task can be interchangeable. We haven't really investigated that. And we haven't ruled out the possibility, I guess, that that's what's happening in these tasks here. The other way around is you could be committed to a task and the person could be interchangeable. And we have not in these experiments, but in other ones we've done agent swaps where you develop a commitment to do a task with a person and then you switch partners, and the effects of some of these factors have been diminished. So we've looked at that side of it, but not the side of commitment to a person, sort of, that you're talking about. That's a good question.
Great, thank you.
All right, so thank you, John. And now we're moving on to our final speaker, so Ingar Brinck. Ingar? Your mic is
Yes.
off.
Yes, now, and wait a second, I'm going to do this, and that, and is this okay?
Yes.
Yes, and you hear me?
Mm-hmm.
All right. Okay, so yes, social norms for human-robot interactions. So let's see here. Yes, how do I do to change them? Yes, so what I'm going to talk about here is, well, first I'm say something about social robotics today, what social robots we have to work with, and then I'll bring up the approach from social norms and how they might help with these problems that Elisabeth introduces to, and then I'll say something about how we can actually design social norms in social robots, and also introduce the robots we have in Lund at our robotics lab. So to begin, the motivation and prediction problems. So this is about motivating interaction from the user's perspective, and also make it possible to understand what the robots are doing. And of course, this is very important because social robots, they operate in human environments, they interact with us, and we're supposed to perform the same tasks together with them. And even sometimes they operate on us. So we can work together with a robot who is, or that is, working as a nurse, but we can also be the patient that is being treated or helped by this robot. And the more of these things that we sort of buy into, the operation in human environments and co-working and even being subject to their acts, the more important it seems, of course, that we feel motivated to be there and that we can predict their behavior. So what do we have today? Well, there have several different kinds of social robots. And this means that there is not one single answer to the motivation problem or to the prediction problem, because it all depends on what kind of physical, what body they have, and what they do, how much, what kind of motivation, for instance, if they are fun or if they're supposed to do something for us, and then if they succeed or not. So the first paradigm today, important paradigm, of course, is the android robots. So you can see here Aiko and Sophia, and they are human-like. And the idea is that the more human-like they are, the more fun and motivating it will be to interact with them. The problem is that it's very difficult to make these complex robots, and they're very, very decades from succeeding, actually. And it's very costly, and it lots of resources they use, and so it's not very sustainable. And the functionality is restricted, actually. So Sophia, for instance, she's supposed to be able to walk, but very often she's in a wheelchair and she seems to be conducting a real conversation, but the dialogue is scripted. And also, although she has 60 different emotional facial expressions, there is something, she's not really synced to what's going on. And so there is something creepy about this, and it doesn't work very well. So the second paradigm, that's the sociable robots, where we have robots as friends. And this paradigm is more successful, and the robots are not very, I mean, the design is not very complex. It's difficult, but it's working for the most part, but they don't do much. So it's all based in imitating emotion and reciprocating emotions, so to speak. So they can show emotions and you react and so on. And the idea is to make you feel good and to motivate you. And as it says here about Pepper, that you see Pepper on the pictures, that Pepper is supposed to welcome you, inform and amuse you. And then it's added, Pepper can also play and dance. Okay, that's very good, but do we need it? Well, then there is Now, which is more useful and is into edutainment, but it's limited what Now can do. And the most important thing about this is that these sociable robots, they can't really reciprocate, and nothing happens. So we interact with them, but the interaction doesn't develop. So in that sense, it's very, very different to interact with a social robot from a human. But then how are we going to be able to work together with them, to actually perform the same tasks and so on? It's not the way we do it, we humans, when we do things together. Because then we reciprocate and we respond to each other, and each action that we do means that the activity that we are in is progressing. But how could it happen here? Well, here actually is another social robot that is able to adapt and learn. So this is Paro, and he's supposed to calm people ill people, or terminally ill people, or people with Alzheimer's disease and so on. And he learns how to behave to satisfy their needs. Another problem that is brought up, that actualized with Pacherie, is that that the sociable robots may not be ethical. So, for instance, Pacherie, some people say that it's really respectless. It's not dignified to let people who don't recognize themselves, because they are sort of deluded, to interact with a robot pet. Why don't you give them a dog at least, you know? And there are more ethical concerns. So the first one, of course, is this illusory problem, that it's deceptive, the whole paradigm. And then there are more practical problems, that they promote trust in the users. So users are liable to start sharing private information. This can be information that you are not supposed to share. And then this information, in the end, it can turn up anywhere in the end on the internet, or, you know, frauds and so on. And then there is this emotional attachment to a machine that they promote, which is also some kind of threat to not only to the dignity of the users, but also to their mental health. So they're also mobile, and the more mobile they get, and the more information they gather, the more dangerous it is, because they might gather information that shouldn't be spread, that you have at home. But then suddenly appeared Lovett, which has the function of spreading love. And it's made for lonely people in Japan. Is quite new. And what's interesting here is that the ethical sort of understanding of the function suddenly changed, because although Lovett actually works exactly like the other ones, they're based in creating emotional attachment and bonds and so on. This now is the good thing about this robot, because Lovett is supposed to be help with the great big problems we have in society today about the aging population and the increasing number of lonely people. And these problems are so important, it seems, so it doesn't matter if we harm or sort of violate human dignity and integrity and so on. It's very interesting. So here, love it again, two of them. But really, this is not what the industry promises, I think. So social robots for social interaction that should, give us the benefits of working together, helping us with problems and all that. They should be autonomous, they should be adaptive, and they should be responsive. They should be more human. How else can we have them, as co-workers or guides and receptionists and nurses and all that? Well, so one way that we have sort of thought about at Lund and are working with is to implement or design social robots that behave according to social norms. And the benefit with social norms in this context is that you have a shared perspective on the world from that the user and the robot share. So this will be motivating. You have some kind of, you create a we, and of course, if you share the social norms about behavior, then this enables prediction and understanding. So if it's possible to design social robots that sort of comply with or react to social norms, probably this would be good. So the benefit of social norms is that they facilitate everyday life. Everything we do almost is sort of made in response to some kind of social norms, or manifest some variety of social norm. They organize and activities, and they also make activities stable. So this is good for prediction, and we can also plan to do things with other people. We can expect them to behave in a certain way. And they also enable procedures and strategies for monitoring and controlling social activities. And generally, their presence in a society, if they're stable, encourages cooperation. So you get more people to engage in cooperation and form social networks. And this is also something that we would desire, I suppose, if we have these social robots. So now there are two major opposite stances or understandings or theories about social norms today. And this is a rule-based one where you think about social norms as verbally formulated or verbal, and that they're engaging in normative activities, some kind of reason giving and rational practice, and you follow rules that are well formulated, and then they are enforced. They're sort of imposed from above. So the opposite, or another alternative position, which is not necessarily, and I want to emphasize that, not necessarily opposite, because you can have both kinds of norms in the same society, of course, is that social norms are embodied and embedded in environment. So normativity is a practical skill, consists in some kind of behavior coordination that requires sensory motor cognition and not reasoning, and it's some kind of emergent behavior. So it's not imposed from above, but it's motivated by the context and the material and the physical environment. So embodied, this is the embodied, embedded perspective of social norms is what we've been thinking about. That's to sort of, well, for the design question in the robots we have, because that makes the norms present, physically present in the robots and also in the humans. And so you can get human and robot to interact and sort of create behaviors together. So social norms are some kind of collectively approved patterns of behavior, and then when you do an action, is you sort of manifest, this is how you do this, or this is how you should do things, and then people react and they either approve or disapprove. You have this thing going on all the time. They're subject to change, variable. So if things change in the environment, then you don't have to wait for the law or somebody else to come in and tell you, well, it's okay if you do it otherwise, but you can just, you know, change with the environment. And they're also entwined with things, physical, temporal orderings and spatial structures and artifacts that help you act in the expected way. So artifacts are function in ways that are aligned with the norms, and the norms then are aligned with the artifacts, so you get some kind of entwinement. So I too will say something about Christina Pacherie. She had the Pufendorf Prize at Lund in 2015. This is the picture to the right. She analyzes social norms in terms of empirical expectations about what other people do, most other people tend to do, and normative expectations, what other people expect you to do, or expect that you should do, rather. That's the important thing. So a social norm is not about following the majority, but it's about doing what the majority thinks you should do. And in Pachérie's version, the social norms are unspoken, and she also thinks about them as behavior patterns that emerge in contexts, and they are not codified, not enforced from above, and the sanctions are informal. And you learn them by participating in activities simply. So they emerge, and you learn in and by and from doing things with other people. So you have some kind of very fundamental, simple mechanisms of alignment where by default shared expectations have a priority over personal expectations, and normative expectations are more important and more relevant than empirical expectations. And you have this herding behavior. People want to do things together, and they want to be liked and be right. And it also seems that people have a tendency just to internalize norms, which might be because it's really practical. So you have reduced cost for processing. If you have a community or group, there will be reduced cost for processing information about behavior generally, easier to monitor what people do, and you don't have to punish people as much if norms are internalized naturally. Sorry. And there will also be a better basis of acting because you know what to do. So if we now think about again the perspective from robotics. So suppose that this theory about norms is correct. How do you get people and robots to share norms? Well, suppose that they can learn from each other, and that norms are embodied. That means that they are perceivable. And so you can see them from how people look and their facial expressions. You can see if people, if the way people look, they look where they want you to go or at the thing that they want you to use, and so on. This is manifests a social norm. You're supposed to do that or use that tool and not the other, and so on. And facial expression shows the disapproval and approval. And then there's also movement, motion, and place in space, communicating where you should be, how you should do, what kind of movements you should use doing something, and if you should, for instance, if you the motions, the large, small, or motions, and so on. So all this communicates normative expectations all the time. And one thing which is important here is that you can perform precise movements and subtle and smooth movements, because the better the movements are. Now we're thinking about the robots and also people, of course, but the more exact movements and the smoother and so on, the more precise, the more information you get and the more information you can transmit. And so this improves the interaction. And also when it comes to acceptance and motivation of social robots, if they are capable of biological movement, it increases the desire to interact with them. So this is important, that you have, that your robots actually are capable of moving in the right ways or in the appropriate ways for social norms and so on, and can locomote, and also that they are capable of seeing and also follow gaze, and that they react to and show facial expressions of motion. So we need these things to design social robots that can behave according to social norms. So this brings us to the implementation problem, because not all robots today, and not any robots that are used in general to make experiments about how people interact with robots, are capable of these things. And so what you also would need is some kind of form of unsupervised learning, because you need robots to be able to learn from people how you're supposed to behave in a certain context. And you can learn them by communicating and picking up expectations, normative expectations from perception and inaction. You can also use role models, so you can make the robot follow a certain person that you want the robot to imitate, and not to look at other ones. And you of course, you need the robot to be able to distinguish somehow between the purely instrumental expectations and social expectations, and the social empirical and the normative ones. So this is a picture of Epi at Lund, and Epi is capable of smooth movements, of unsupervised learning, and can vision and grasping things and so on, and moves on a mobile platform with wheels usually. So we don't consider walking well, it's important for some kinds of social norms, but we can actually test, use Epi to test for social norms in HRI. And this is something we're working on, and we're going to do some tests next year with Epi. What we think is central is that human and robot are resources for each other, because often people are designed as obstacles for the robot. The robot is supposed to make a large detour, not hurt, and so on. So the environment is safe. But actually, the more they interact and the more they help each other, the better it will be for the robot and the human. And so you want them to show when they don't know something, and to act in ways that are conspicuous, and to satisfy each other's expectations. And actually, when you get people, if you have a robot that is inviting and that is asking for help and so on, then people want to be with it, and they start to do the same thing. So there's some kind of reciprocation that gets going if you just design the robots to be to need your help and to be social. So here's another robot that there was we had made an experiment in 2010, I think, with the builder robot who was learning how to design stack cubes with different colors and so on. And actually he was exploring, or she was exploring and imitating what the experiments were doing, and was learning what to expect. And as this went on, the interaction went on, the builder robot ended up distinguishing between what it did and others did, but then to recognize what most experiments did, and then in the end to recognize also not only what most did, but what most of them wanted or thought you should do, and not only how they did. So in the end, it actually reacted to, or responded to, the normative expectations of experimenter.
Ingar, it's time you conclude.
Yes, so this is Epi, and this was just some examples of how you could do to get social norms to support HRI. Thank you.
Thanks a lot, Ingar. If you could unshare your screen.
Yes, and how do I do that?
Well, same place where you share it.
Yes, here. Okay, thanks.
So thanks a lot. And
thank you.
So we have 20 more minutes, and we must stop on time because we have a plenary keynote right at 3. So let's start with a few questions to Ingar, and then we can open the general discussion. So questions to Ingar? So 2 people have raised their hands, but I don't see who they are. They don't give me the names. So let's start with Gloria.
Gloria, Elisabeth.
Okay, Gloria.
Okay, thank you. That was really interesting. I wanted to ask you, how can you uphold this distinction between normative and empirical expectations if you take this embodied and perceivable picture of normative expectations? So I think I agree with your picture that these norms are embodied and perceivable, but I would also say that then ultimately the normative expectations are empirical expectations about how the others in the social practice will respond and what they will think is correct in this practice. So I think they will collapse these two.
Yeah, well, it has to do with correction. So you can see what people do most of the time, and then you can see if what they do most of the time is corrected or not. And so it has to, well, that's the answer simply. So you correct what is, you don't correct what answers to the normative expectations, but what, yeah. So the robot will learn to do, to not do what is corrected and to do what people do. Yeah, you can't do that. Sorry. So actually, I mean, it will, in the end, because you iterate this interaction, in the end, it will be able to worry that this is what happened, actually. So, yeah.
All right. So second question is from Anna Molchanova. Anna, your mic is off.
Okay, yeah, actually, my question was identical to Gloria's. So it's a follow-up then. So why is it different with robots if you say normative expectations involve corrections? Like if a robot puts its hand on something hot and it melts, I'll tell it not to do it next time, right? So like then in this case, empirical and normative would be kind of the same, no?
Oh yes, but so this is this framework supposes that you have a robot that is capable of learning, and it's dedicated. So you have it in for a specific kind of task. So, for instance, it helps you with your laundry, or it's stacking cubes with different colors. And then this is a task environment where you usually engage with the robot, and it will pick up behaviors as you interact. So it doesn't come with the social norms, but you have to teach it. And it will ask you, it will show when it doesn't know. And then it will ask you to repeat and test. It will test its behavior. So this will make it possible for it to distinguish between what's done, what it should do, or just what people can do, and so on.
So.
Okay.
So, yeah.
Glenda has a question?
Yeah, can you hear me?
Yeah.
Yes.
Yeah. Okay, thanks, Inga. That was very interesting. And I think I agree with almost everything you said. But I have a question about, you said that we should expect social robots to be adaptive, responsive, and autonomous. And I can see how they can be adaptive and responsive. But I would argue that there is more to autonomy than what you describe, especially because I guess we expect children, for example, we call children autonomous when they are able to, for example, impose norms, or decide not to do something, or even create a norm. So I would say we should stop short from attributing this to these robots. But I just want to know more about what you think of that. Do you think they show autonomy? Do you think that's maybe not something they do?
Well, I think that if you have this scenario, so suppose you have this laundry robot, or it helps you with different things at home, then it's really an advantage if the robot can make you behave in a way that is suitable for its capacities. So the same manner that it tries to imitate you and sort of adjust its behavior, so you can make the most of it. In the same way, the robot should act so as to help the user to sort of adapt and make the most of that. You see, so that's why we need the autonomy. So in this scenario, this is very different from how people do now, because they pre-program and they train, but the idea here is that if you act proactively together, reciprocally, and that you act to improve, so you can actually together reach the goal, and this is possible to do. We can do that with robots, but people don't generally do it, because you also need it's necessary for the real world context too, because it's changing all the time. So you have to have these robots that can learn from significant others. So yeah, but you need autonomy for this, because otherwise also there are several tests that show that if you have a robot that acts in this way, that sort of asks questions, asks for help, and shows you how to interact, then actually people will do this, and they will just do it more and more. So they get involved, and it's like a like a spiral, and you get tighter and tighter interaction. So I mean, I can't be sure because we don't have it yet, but it's possible to realize this design, and I think it's a much better way to go than to try to pre-program robots, because really the real world is dynamic and changing all the time, and we can never catch up with it, if we want real social robots, that is. So autonomy in that sense, but not, so that autonomy is delimited, restricted to the context, to the task environment, of course. It's not real autonomy in that sense.
So thank
Okay.
you again, Inga. And now we're opening the general discussion, so we only have 12 minutes, but basically now you can ask questions you didn't have a chance to ask to also to the previous speakers or to the whole panel. So, who's Anna Strasser.
Okay, I'll try again to find out what the conditions are under which I'm justified to say that a human-robot interaction is a social interaction. This mainly goes to Raul, but I think John has to say something about that as well. So as far as I understood, you're saying it's reasonable to take an intentional stance because it helps me to predict, to coordinate, and to trust, and to act jointly in a proper way. But I'm asking myself, how do you justify it's reasonable? So couldn't you go for a more radical way and say, I do not need to take the intentional stance, I can interact with this robot without doing that. And then you have to answer the question why you still call this as social interactions. And the other side would be the example I introduced in the first question I had, is if we have pretend play, we also, I would claim, have an intentional stance, and it's reasonable to have the intentional stance, otherwise the pretend play is not working. Why we do not call this a social interaction. Thanks.
So Raul, your mic is off.
Of course, of course. Okay, so let me see. Now I'm not quite sure if I've got both parts, but it's about this reasonability of taking something to be social interact or taking the social stance. But first you asked, you find it difficult to see what exactly is social interaction in this case of robots. And I'm saying that I don't know the conditions of this proper social interactions. I mean, there are many definitions, and I looked at Gilbert's, and that's one candidate, but I think it's a little bit too strong, perhaps because I don't think that all social interaction is necessarily joint action. I mean, she is focusing on these we phenomena where people have collective goals and all that. I think it's a little bit too strong because I don't think that all social interactions are necessarily these we phenomena. I mean, it's social interaction when we coordinate in street, when we meet someone and say hi and they say hi and all that. It can reasonably be called social interaction, even though it's not, it doesn't involve a plural subject or anything like that. Okay, why is it reasonable in some cases to take this social stance, which, as I said, doesn't amount to this real social interaction, real sociality, but it's a reasonable way, reasonable stance to adopt whenever we are trying to interact with some object or agent, and we can't do it simply from these lower level stances, the physical and design and intentional stance. If in order to predict its behavior, we have to attribute it the capacities of being able to distinguish agents and non-agents, and perhaps follow some social norms or conventions and so on, then it is, in my view, reasonable to take this social stance. And we don't need to do this when we are involved in pretend play. Maybe we are taking this intentional stance or even a social stance when we play with our doll, but it's not something that is required by the interaction, because I don't really need to coordinate the doll's actions because I'm controlling the doll. So in that sense, I said that this is pure pretend play, and it doesn't, in this sense, require this social stance or even an intentional stance.
So Gloria had a question.
Yeah, thank you. It was about autonomy and about Raul's argument that, like, about the difference between persons and robots, and namely that the fact that the robots achieve their cognitive capacities through programming and engineering makes them not autonomous, and this constitutes manipulation. And I thought like that this fact alone, that there is a programming, this does not do away with, is not different from human agents as such, because I mean human agents, I mean they have some initial potential that is inborn, and then they develop the cognitive capacities in education and interaction. And likewise we could say like the software has a certain programming, and then it trains and develops in interaction. And I think there is much more analogy, and
Yes.
I think the difference must be somewhere different, like which ethical purpose you have with this, or that it is more broad in humans, or more you want to develop the child for its own sake and not for a particular purpose, or something more ethical. And I think there is more difficult, this
Yes.
distinction.
It is, and I cut some corners in presenting the argument. The real important point there is in what Al Mealy calls these unshreddable pro-attitudes, which means that someone's actions are not autonomous if they are a result of goals or pro-attitudes that have been imposed on them. They have not selected them by themselves, and rather they are a result of some kind of a manipulation. Their values or goals or desires are a result of some kind of a manipulation. And I think that this is the case also in robots, because robots, it's not just that their capacities are being programmed or engineered, because we also, many of our capacities are well, not result of our own activities, but something that we are born with or developed with. But rather, the point is that in order for robots to use these capacities, in order for robots to do something, somebody must program in an algorithm telling it what to do. It doesn't have any goals that it has chosen itself. Whereas we, at least that's the assumption, we somehow can select our own goals and values.
Sorry, Glenda, the question?
Yes, I guess could be a follow-up in some sense. So, it's a bit for everyone. I think for all, maybe mainly, but I think for everyone, which is one of the things that people relate to social norms. It's or conceptually, it's the possibility of making some kind of special mistakes. So, for example, I can know that the way that I should appropriately dress up to go to a wedding is by wearing, you know, smart clothing, and I might decide not to. So I might trump the norm, and that's why people say that, you know, the exception makes the rule in a way. So I was wondering if robots. So one, I would say that if a nation is not capable of doing that, maybe the social stance doesn't apply. But in general, I wonder if any of you think that robots are able to do these kinds of mistakes or errors.
I would just quickly say that, okay, maybe it's possible, I'm sure it's possible. Maybe it would be intentional in the sense that the robot realizes that this is what is expected, but for some reason it decides to deviate from it. It's possible, but again, it's still social. The social stance doesn't require that it always follows the norms, but at least it shows some sensitivity. In order to explain its behavior, you have to refer to social norms. But I'm sure that Ingar could say more about this.
Right, but I mean, the case is, it's that, so what wouldn't work is that if the robot simply doesn't conform to the norm, then you don't need the norm to explain the behavior. It's only if you can say, like, the robot knows the norms, but somehow decides not to act upon the norm, that you need the social stance, right? So it has to be something that you can attribute the robot the norm, but still the robot doesn't behave according to the norm.
Yeah, that's right. If in order to explain its behavior, you have to attribute to it some kind of an understanding that there is a norm in place, then the social stance is warranted. But there might be better ways of explaining his behavior. I mean, this often happens that we realize that, okay, it doesn't really behave as we expected, and we go back from the social stance and the intentional stance to perhaps the design stance. We realize that, okay, this robot doesn't respond to my interaction, so, and we start thinking about, okay, I could have programmed this a little bit differently or something like this. So this is, we go back to the design stance.
All right. Ingar or John, do you want to add something? No. So I think we must close because a keynote, so Jonathan yeah, sorry, thank you, is now giving a keynote, so we must leave on time. So let me thank our speakers, thank all the participants, and hope we meet soon again for real.